So when we're doing delta T, when we're figuring out the change in temp, we're doing the final temperature minus the initial temperature. Even though this is a kind of an easy one that, like, if you read it through, you might be able to do this in your head, we're still practicing the same habits of identifying those givens, writing them down, writing down the equation, and then doing the math, plug and chug. Because especially with this, you want to be careful that you don't mix up your final and your initial temperatures. That's an easy thing to do. So when we do this, we're going to be careful to identify which one is final, which one is initial, and then when we finish, we're going to look at the sign on it. Is it positive or is it negative, and does that make sense? So if the temperature is decreasing, is the sign going to be positive or negative on your change in temp? It's going to be negative because your change in temp was negative, your temperature decreased. If your temperature increases, if I say this morning it was 0 degrees and then it got up to 10 degrees, my temperature increased, is my change in temp positive or negative? Positive. It's positive, and we should see that. So when we do the math, when we finish, make sure you always check your answer and think to yourself, does that make sense based on what the problem said? Okay, cup of water, cooled down from 80 degrees Celsius to 60 degrees Celsius. What's the change in temp? What's the final or initial? Well, give me a given. What's a given? Okay, initial, and I write it like that, capital T, subscript, lowercase I. Initial, it started out as 80 degrees Celsius. What's the other given?
The final is 60 degrees Celsius.
Good. And I'm trying to solve for delta T. What's the equation I'm going to use? Yeah, delta T equals final minus initial. Then I can plug in those givens. So when I plug in those givens, make sure you're plugging the right given to the right spot. You're keeping track of which one's final, which one's initial, because otherwise you're going to mess up your sign. And that sounds dumb, but it's really an easy mistake to make. So that's why you want to make sure that you be careful to identify which is final, which is initial, and keeping track of them. So final is 60 degrees Celsius minus initial is 80 degrees Celsius. Do the math.
Minus 20 degrees Celsius.
Negative 20 degrees Celsius. Good. So the sign on that is negative. Does that make sense? What does that mean that the sign is negative? What are we saying about a change in temperature?
That is decreasing.
The temp went down. Does that make sense with what the problem says?
Yes.
Cup of water cooled down, temp went down, our sign should be negative. Good, that makes sense. Ready for the next one? Okay. Metal slide is heating up in the sun. In the morning it was 10 degrees Celsius, and by afternoon it reached 25 degrees Celsius. What's the change in temp? List our givens first. What's a given? Initial is 10 degrees Celsius. What's another given?
Final is 25 degrees Celsius.
Good. Change in temp is what we're trying to solve for. So that means the equation I'm going to use is going to be delta T equals final minus initial. Then I can plug and chug. Plug my givens in, make sure I'm keeping track of which is final, which is initial. What's the change in temp? Positive or negative?
Positive.
Okay, what does it mean that it's positive? That the temperature increased. Good. Does that make sense with what the problem says?
Mm-hmm.
Yeah. Okay, good. All right, do the next two and then we'll check them together. All right, as a storm moves in, the air temperature suddenly dropped from 4 to -5. What's the change in temp? So first we're identifying givens. Let's see if I can do that. Final temp. So this one, because one's a negative and one's a positive already, like just be careful that you're keeping track of finals and initials. Final is -5. Initial temp is 4 degrees Celsius. It went from 4 to -5. Solving for delta T. So that's the equation we're going to use. Plug in the final and initial into the right spot, and you end up with -5 minus 4. -5 minus 4 gives you -9 degrees Celsius. If that change in temp is negative, that means that your temperature decreased. Does that make sense with what's happening in the problem? It says the temperature dropped. Yep, that makes sense.
Yeah, I really needed. The one thing about math is you learn how to add the opposite. Now, if I don't do it, I
Yeah.
don't get it anymore.
Yeah.
Like, I have to do it now because she's like engraved it in my brain.
So instead of -5 minus 4, you're doing -5 plus -4?
-4.
Yep, and that works, absolutely. Yeah, that's a good way to think of
I
it.
don't pick up on that. So I was getting -1. I was like, that doesn't make sense.
Right. Yeah. Yeah, so either do it like that, or what you could also do is you could also like picture a number line. Well, if I start at -5 and then I'm going -4, I'm going back 4, well, that's going to get me to -9. So either one of those. All right, number 4, it's chilly in the house and the heat kicks on, raising the temp from 21 to 23. What's the change in temp? Final temp is 23. The initial temp is 21 degrees Celsius. Went from 21 to 23. Solving for change in temp. This is the equation we're going to use. Delta T, change in temp, plug in these finals and initials, equals 23 degrees Celsius minus 21 degrees Celsius, gives you a change in temp of a positive 2 degrees Celsius. It's positive, that means temp went up. That makes sense. That matches with what it said in the problem. All right, questions? Okay, show me thumbs up, thumbs down, somewhere in between for the...
Wait, the last that was -2?
No, this one's positive too.
Oh.
My equal sign just looks weird.
Oh.
There we go. All right, change in temp, show me thumbs up, thumbs down, somewhere in between. Okay, because when we go into these next steps, we're going to kind of incorporate the change in temp into there.
Okay.
So we're going to kind of combine a step here. So I know I really, really hammer hard that we do, we identify the givens, we write the equation, we're going to plug and chug. We're going to well, if I could talk, going to kind of like combine some steps here. So let's look at, oops, I want to go back to here. So let's look at number 1 under this one. This now is the equation that we're using, the Q equals M delta TC. So thermal energy, mass, change in temp, specific heat. Number 1 says a mug containing 200 grams of hot water slowly cools down from 98 degrees Celsius to 90 degrees Celsius. What's the change in thermal energy? The specific heat of water is 4.18 joules per gram degree Celsius. So remember that number there, that constant is listed on here, but honestly, you're going to use it so many times, you're going to memorize it. You're going to use it constantly. Okay, so what's a given? What's given in the problem?
200 grams.
200 grams is a measure of what? Mass, good. What's another given?
Change in temperature.
Okay, so here's how I'm going to do this. I'm going to write it out like this. So change in temp equals my final minus initial. So it cools down from 98 to 90. So it's going to be 90 minus 98 equals my change in temp is going to be a -8 degrees Celsius. So I write it down all in one step like this. And I would absolutely encourage you to write it all out like that. Don't just do this part in your head and then skip to that. Because if you're making a mistake, you want to have this written out so you can go back and you can see it. Because sometimes what's going to happen is you're going to go, oh, shoot, you know what? I mixed up my final and my initial. So write all of that out. Delta T equals final minus initial equals whatever the math comes out to. One more given. What is it? Yep. And then what are we solving for?
What is the change in thermal energy?
And what variable do we use for that?
Q.
Q. So thermal energy is what we're solving for. The variable is Q. Well, rather, the abbreviation is Q. So if I'm trying to solve for Q, what's my equation going to be? What equation am I using?
Oh, let's see. Mass
Q
times change in temperature times.
Yep, equals Q. So Q equals M delta TC. We're solving for Q. We have mass, we have delta T, we have C. Now we can plug and chug. So as you plug these things in, Q equals, I always put parentheses around each of one of my quantities, 200 grams. Delta T is -8 degrees Celsius. C is 4.18 joules per gram degrees Celsius. Okay, I want to show you some of the units here, but I'm going to find a piece of paper because I would do it on the board, but I want to do it so I can see it in the video. So let me find a piece of paper. So we can make it nice and big and bold and obvious. Okay. All right, so here's our equation. We have, can I see if I start over here? There we go. Q equals 200 grams times, what was it, -8? -8 degrees Celsius times 4 point, oh, my piece is in the way right here. Times 4.18 joules per gram degrees Celsius. Remember that we can do all the same math that we can do with numbers. We can do the same math with units. So what's 2 divided by 2? What's 412 divided by 412? What's 792 divided by 792? What's 2.4 divided by 2.4? What's anything divided by itself? 1. Anything divided by itself is 1. So what's grams divided by grams? What's anything divided by itself? Anything divided by itself is 1. What's 10 divided by 10? 1. What's grams divided by grams? 1. Anything divided by itself is 1. So right here, we have grams on the top and grams on the bottom of a fraction. So we've got grams divided by grams. What's grams divided by grams? 1, which means they cancel. So we're going to cancel, grams cancels out. Because we have grams on the top of a fraction, grams on the bottom of a fraction. So grams divided by grams equals 1, which means it cancels. What's degrees Celsius divided by degrees Celsius? 1. Anything divided by itself is 1. So we have degrees Celsius up here, degrees Celsius on the bottom of a fraction. So it's divided by itself. Anything divided by itself is 1, which in the case of units means it cancels. So what units is Q going to be measured in? Or calculated in, I guess? Joules. Is that good? Does that make sense?
Yes.
That's exactly what it should be, right? Because we're calculating thermal energy. Thermal energy is measured in joules. So we did, right now, we did the whole problem. We just did the math in the units. And did the math in the units come out right? Yeah, right? Yeah, math in the units came out right, which means it's a really good clue that all of our numbers are set up right too. So as long as we actually plug it into the calculator right, we've got everything set up right. Okay, so then plug it into the calculator. Remember, I'd really encourage you to use a calculator, so go borrow one or get your own.
I did, but I don't think I did it right. So
Okay, so you're checking?
yeah.
Because if you know how to set it up, but you don't know how to actually use one of the calculators when it comes to a test, then you're not going to be in good shape.
Oh, I did use it.
Good. Plug it in.
I got it.
Did ya?
Yep.
Okay.
Made it cool.
Well, let's just hang on just a minute. We got a couple more people plugging it in still.
Is there a negative sign here? Or do we just
The
use
top
this?
left, the plus and minus sign.
Yeah, does it say like plus slash minus? That's gonna be able to, like you put in your 8 and then hit that one and it'll turn a negative.
Okay.
So just looking at the numbers that we have here, should your answer come out positive or negative? It should come out negative, right? So when it comes out negative, what does that mean if your Q is negative?
Decreasing.
It means it's decreasing in heat energy. It means it's losing heat energy, or it's cooling down, or also it's going to mean your temperature is decreasing. All right, what's the number?
Negative 6,688 joules.
Joules. Nice job. Good work.
I did that.
All right, try plugging in again.
Wait, so 200.
Times -8. So you're going to plug it in like,
It's a negative after you.
yeah, so do 200 times, you're going to plug in 8 and then the negative sign, times 4.18 equals negative 6,688.
Oh, okay.
All right, first problem we've seen like that. Show me thumbs up, thumbs down, somewhere in between. Okay, why don't you try the next one on your own and then we'll check it. All right, where are we at? 20,000 gram metal slide heats up in the sun, increasing its temperature from 15 degrees Celsius to 20 degrees Celsius. What's the change in thermal energy? Specific heat of the metal is 0.45 joules per gram degree Celsius. All right, so here's our givens. Mass is 20,000 grams. Change in temp is final minus initial. So it was at 15 and then it went up to 20. So 20 minus 15 gives us a change in temp of 5 degrees Celsius, positive because it heated up. Specific heat of the iron, of the metal, is 0.45 joules per gram degree Celsius. Q is what we're solving for, which means that's the equation that we're going to use. Plug in each of the givens into there, do the math and the numbers. Is that what you got?
Yeah.
Looks good? Okay, awesome. Any questions? All right, then switch sheets.